Hi everybody, welcome to another video in Math 1332, section 11.4, Fundamentals of Probability. Theoretical probabilities. A probability experiment is a process that leads to well-defined results called outcomes. So outcomes is the result of a single trial of a probability experiment. Just going to underline what. A sample space is a set of all possible outcomes of a probability experiment. Here we have some example. Flipping a coin, the sample space usually denoted by S, and we're just going to list all the possible outcomes. Flipping a coin, that will be a head or tail. And rolling a standard die, has 6 faces to be 1, 2, 3, 4, 5, or 6. So those are the possible outcomes. That will be sample space. Flipping 2 coins. The first one we have head or tail. The second coin can also have head or tail. So when we write the sample space, head, tail, tail, head, and tail. Right, so just list all the possible outcomes in the set, and that's called the sample space. Now, we have a sample space. Next, we define an event. An event is the subset of a sample space. So we might have something like that. Just sum of the possible outcomes, that will be an event, and the subset of a sample space. Let E be the event of sample space S, and E is the number of outcomes in E, and NS is the number of outcomes in S. Then the probability of E given by this will be the number of elements in E divided by the number of elements in S. Or that's what we have here. Right. So how many we have in a particular event divided by how many we have in the sample space. Right, just like that. Now we have this problem. A single die is rolled for the 3 events listed below without calculating probability, putting in order from the list to most likely based on educated guess. After that we find probability. Now just guess. Getting the 5. Getting a number less than 5. Or getting an odd number. Right. Of course we're going to guess. But we have to guess. A die may go from 1 to 6. Less than 6, I mean less than 5 is certainly more than a 5. So this probability, this should be much higher than that. And an odd number, they look like that 1, 3, and 5. And less than 5 probably still more. So that first, that second, and that third. Alright, how we actually do it. First, we have a single die is rolled. So we're going to list single die. 1, 2, 3, 4, 5, and 6. Those are the outcomes for a single die. Now, getting a 5. So we let E be an event, and that event of getting exactly a 5. So in that case, the probability of getting that event is N of E over N of S. N of E is 1. N of S. There's 1 in E and 6 in S. So that's 1 out of 6. So that is probability of getting a 5. Right. A number less than 5. We will list everything that is less than 5. 1, 2, 3, 4. That's it. So the probability of getting that event is the number in E divided by the number in S. There are 4 of them in E and 6 of them in S. Reduce, that will be 2/3. Of course, we can convert that to decimal, but that's not the point. Right. Getting an odd number. getting an odd number. So an odd number, let's write that event of an odd number 1, 3, and 5. Probability of that event is over ns 3 here and 6, 3 in this and 6 in the sample space, or reduce to 1/2, or you can write 50%. Right, but straightforward. Right. Next, 2 cones are flipped. Find the probability of getting 2 heads, at least 1 head, and at most 1 head. Right, so sample space. We did this previously. The sample space will be 2 cones, will be head, 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 tail, tail, head, and tail, tail. Now probability of getting 2 heads. That event getting 2 heads will be just head and head. Therefore, the probability of getting that is probability of getting it's a number in the event over the number of the sample space. So 1 out of 4. 1 here, 4 there. And probability of getting at least 1 head, we write the event getting at least 1 head. At least 1 head, so that is good. 2 head is okay. That is okay. And that is okay. So the probability of getting that probability of getting the event will be 3. Getting 4 here to be 3 over 4. Right. I said if we can list everything in the sample space and everything in the event, we can find probability easily. Now at most 1 head, so 2 head is too much. Head, tail, so that 1 head is good. 1 head here is good. Tail, tail. So probability of that again is 3 in that event and 4 in the sample space. Right. Of course, we can write this as 75%, but 3 over 4 is good. Right. Probability. Property is a probability. Probability will never be negative, and it's never greater than 1. So meaning that probability of any event is between 1 and 0. When event can't possibly occur, it is probability of 0. When event is certain to occur, that is probability of 1. And if we add probability of every single outcome in the sample space, the result is 1. Right. So those are the theory of probability. We just pretty much count how many we have in the event divided by how many we have in the sample space. That's all. Next, empirical probability. This is empirical, mainly from experiment. Let's see, we have it's just how many we see in that event divided by how many we have totally. Right. So look at this. If one person is randomly selected from the population described as below, I should say below, find the probability that the person is female. Right. So when we look at this, the total there 242, and female total is 124. So probability of having a female selected will be equal to 124 out of 242. (62) over 121. Right. So just empirical probability. So they have to give us the data like this in order for us to find the probability. But that's all we have. That's all I want to go over for this section. As always, thank you for watching, and see you in another video in Math 1332.